Now, one thing you're going to have to do is you're going to have to be able to complete a congruency statement to prove that two triangles are congruent using some sort of theorem that we've talked about, either angle, angle, side, angle, side, angle, side, 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 angle, side, etc. And here's an example. I'm going to have 3 examples of these using the same diagrams, using different congruence theorems. So here we have triangle FGH is congruent to triangle LMN, and we're given a couple of statements that we know to be true. We're told that GH, that side, and MN, that the right-hand side of the other triangle, are congruent. We also know that angle G and angle M are congruent. And we have to have one other piece of information here, because if we're going to prove that two triangles are congruent, we have to have at least 3 pieces of information. We need to have either all 3 pairs of corresponding sides that are congruent. We need to have a couple of angle pairs that are congruent with a side that's congruent, or we need to have 2 pairs of corresponding sides that are congruent with another pair of angles that are congruent. So in this case, we want to prove that these triangles are congruent using the angle, angle, side congruence theorem. Now with angle, angle, side, as the name suggests, we need 2 sets of corresponding angles to be congruent with a side, and they've got to be in a particular order. And in this case, angle, angle, side, we have 2 angles that are consecutive. That means they're basically right next to each other. And we have one of the opposite sides, the corresponding sides that are congruent. So in this case, we have angle G and M. We have the 2 sides that are attached to those 2 angles. But to use angle, angle, side theorem, the side is not going to be the included side. So it's not going to be between the angles. It's going to be one of the other angles. So the only way this could work is if angle F and angle L are congruent. So if that were the case, then we would have in order a pair of corresponding angles, another corresponding angles, and we have a corresponding sides in that particular order. If we wanted to do the same thing using angle, side, angle, given similar information, in this case we're given that FG and LM are the same, they are congruent. We're also given that the same angles we had earlier, are G and M, are congruent, and we now want to prove that these 2 triangles are congruent using the angle, side, angle theorem. Well, in angle, side, angle, the side, the corresponding pair of sides that we know, has to be the included side of the 2 corresponding sets of angles that we have that are congruent. And included means basically that that side is what comes between the 2 angles. It's connecting the 2 angles that we have. So in this case, since N and H, those angles are not going to allow that side to be in between the angles. The one that we need is going to be the same thing we had last time as angle F and angle L. Those would need to be congruent in order to prove that these 2 triangles are congruent with the angle, side, angle theorem. And if we wanted to use the same example, we have FG and LM that are the same again, angle G and angle M. But now we want to prove that these 2 triangles are congruent using the side, angle, side congruence theorem. And with side, angle, side, of course, we need 2 sets of corresponding sides instead of angles, and we need 1 set of corresponding angles. Now the only way this works with 2 pairs of sides and 1 pair of angles is if the angle is the included angle between the 2 sets of corresponding sides that we know. So since we know that FG and LM are the same, and we have that angle to the right, well, that angle needs to be between the 2 sets of corresponding sides, so the other corresponding sides that we need to have are going to be GH and MN. So if you look at these triangles and you just look at the marks in order, you see that we have a congruent side, an angle that's congruent in between, and then congruent sides. So that is side, angle, side congruence theorem.